Hello children, welcome to AIMS India's live class session. Sorry children, sorry for the delay. Actually there was some technical problem. Another live class was going on. So today from physics subject, motion topic we are going to continue. So okay, in yesterday's class we have learned the basics of motion. Basics of motion. So according to direction, regarding the types of motion and some basic terms involved in the motion like position, distance, displacement, speed, velocity, acceleration, retardation, time. So about these basic terms we have learned, and we have discussed about the difference between distance and displacement. So distance and displacement. So here in while any object is exhibiting motion, while any object when it is showing motion or when it is exhibiting motion, it will be again divided into two types. One is uniform motion, another one is non-uniform motion. I think you are all aware of the word uniform. So what does uniform means? Same, because all the children will come to school in same uniform. So uniform means will same. The meaning of uniform means same, means a similar kind of motion, like that. So we are going to learn about this uniform motion and non-uniform motion. So actually, if you observe this picture, what is the picture? What does it represents? A bike. A person is on bike. A person is on bike. He is traveling on a road, on a straight road in the forward direction. He is traveling on a road in the forward direction. So we have this diagram here. So here distance they have given, time they have given, uniform speed they have given. So here in 1 second, actually let this point, let us assume this point is A. Let us assume this point is A and this point is B. Between A and B, what is the distance? 5 meter. What is the time interval? 1 second. Here we are telling time interval. Time interval means the time taken by the bike for traveling from A to B. This time interval is 1 second. Means in this particular time interval, it has traveled the distance of 5 meters. Again, suppose B is the starting point. This is C. From B to C, what is the distance? 5 meters. From B to C, what is the distance? 5 meter. In how much time interval it has traveled 5 meters? Again here 1 second. Again here 1 second. Like that. C to D. 1 second time interval. It has traveled 5 meter. Again D to E. 1 second time interval. It has traveled 5 meters. Again E to F. 1 second time interval. It has traveled 5 meters. So here in equal intervals of time, because here all the time intervals are equal. All the time intervals are equal. So what we can say, how the bike is moving in equal intervals of time, it travels equal amount of distance. In 1 second 5 meters, 1 second 5 meters, 1 second 5 meters. So what we can tell, in equal intervals of time, in equal intervals of time, it is traveling equal distance. It is traveling equal distance. So we can say that this body, what is the body here? The person moving on a bike or the bike. This body is exhibiting uniform motion. So this body is exhibiting uniform motion. So like that we can tell. So like that we can tell. Here the condition is, no matter how small these time intervals may be. So because here time intervals we have taken 1 second. It is not compulsory that we have to take 1 second. We can take 10 seconds. We can take 10 seconds. We can take 20 seconds. We can take half second. So this uniform motion, it never depends on how much small this time interval is. We can take any kind of time interval, but the condition is, in equal intervals of time, it has to cover equal distance. It has to cover equal distance. Then we can say that it is in uniform motion. So this uniform motion. Okay. So next. Here uniform speed. Speed means distance by time. Sorry, here print mistake. 5 meter per second, 5 meter per second, 5 meter per second. This is the speed here. About speed we are going to learn in next slide. So this is about uniform motion. Once again I am repeating, what is uniform motion? So throughout the journey, the bike racer or the person who is traveling on the bike, throughout his journey, his motion is uniform. His motion is uniform. How can we tell it is uniform? Because he is in equal intervals of time, he is traveling equal distance. Equal distance. Okay. So next. So here, if you observe this graph, so if you observe the graph which is on the right side of the slide, how is the graph? What is this graph actually? This is a uniform motion graph. This is a uniform motion graph. Here on the uniform motion graph, on the x-axis, this is the x-axis, this is the y-axis, this is origin, O. So on the x-axis, we have taken time in minutes. On the y-axis, we have taken distance in meters. Here you can observe, this is a straight line. So this straight line is representing one kind of motion. Now, by this straight line, we can tell this graph is showing uniform motion. So on the graph, we have taken x-axis, we have taken y-axis, we have origin, time we have taken on x-axis, distance we have taken on y-axis. I am telling that this line will tell us about uniform motion. How the line represents uniform motion? On the line, if you observe at 1 minute time, how much distance it has covered? How much distance it has covered? 10 meters. 10 meter is the distance covered. In how much time? 0 to 1. What is the time interval? 1 second. Let me erase this one. Now here. So observe this graph carefully. 0 to 1. What is the time interval? 1 second. 0 to 10. What is the distance? 10 meters. What is the distance? 10 meter. So this line, what does this two lines represents? In 1 second time, it has covered 10 meter. Again, if you take from 1 to 2, this time interval, from first second to second second, what is the time interval? 1. Means from here to here, from 10 to 20. So what is the distance travel? 10. So again in 1 second, we should not get confused. It is not 2 seconds. In 2 seconds, it has traveled 20 meters. But from 1 to 2, the time is 1 second only. From 10 to 20, the distance is 10 meters only. Again, in 1 second, it has covered 10 meters. Again, this lines, if you observe, from 2 to 3, what is the time interval? 1 second. From 20 to 30, what is the distance travel? 10 meters. Because after 2 seconds, it is at 20 meters. At third second, what happened? It is at 30 meters. So it has traveled from 20 to 30, 10 meters. Like this, if you observe this graph, if you take any intersection of x-axis, y-axis, any point, what does it represent? In equal intervals of time, it is traveling or it is covering equal distances. So this graph is an example of uniform motion. So uniform motion we can represent on a graph with a straight line. On a graph with a straight line like this. With a straight line like this. So what is the name of this graph? It is a distance time graph, because we are representing distance on y-axis and time on x-axis. So that's why it is an example of distance time graph. Distance time graph. So the distance time graph for uniform motion, it is a straight line. It is a straight line. So if we drop a ball, from roof of a tall building, so then also it will show uniform motion. That we will learn in next regarding acceleration due to gravity. At that time, we will learn about that topic. Okay. Any doubt regarding this one? Regarding this uniform motion? Any doubt regarding this uniform motion? So you can take the example of ceiling fan. If you take the example of a ceiling fan. So how the blades of the fan will move? How the blades of the fan will move? If it is in because for the ceiling fan we can turn the points 1, 2. We can change the speed. If we keep on 2, at that particular speed, it will travel in uniform way. It will travel in uniform manner. Anything which covers equal distances in equal intervals of time, it is an example of uniform motion. Okay. Somebody asking, explain again, sir. Okay, uniform motion means equal intervals of time, equal amount of distance it has to travel. So then we can say that it is uniform motion. Means this throughout the graph, how the body is traveling in 1 second, it is covering 10 meter distance. Like that, it is traveling in a uniform manner. Okay. So if you take non-uniform motion, like this example, here the bike, how it is traveling in 1 second, 5 meter. After 1 second, 8 meter. After 1 second, 10 meter. After 1 second, 4 meter. After 1 second, 6 meter. After 1 second, 7 meter. So here the time intervals are same. But the distances covered by the body are different. Means unequal distance. The body is covering unequal distance in equal intervals of time. So this is an example of non-uniform motion. So here the speed is variable. Variable means change. In mathematics, we call x is a variable. Why x is a variable? Suppose x greater than 7. What is the value of x? I can keep 8. 8 greater than 7. Correct. Or I can keep 9. 9 greater than 7. Correct. So that's why variable means it can take any value. Its value is not constant. Here also the speed of the body is variable. Here 5 meter per second, 8 meter per second, 10 meter per second, 4 meter per second, 6 meter per second, 7 meter per second. So in equal intervals of time, it is covering unequal distances. So this is an example of non-uniform motion. Let's see the graph. So the graph of a non-uniform motion will be a curved line or will be a zigzag line. Will be a line like the zigzag line. Will be a curved line or will be a zigzag line, but not the straight line. But not the straight line. Why means in equal times it is covering unequal distances. Unequal distances or unequal times covering equal distance. Here the time may be equal, distance may be unequal, or distances may be equal, time may be unequal. So one is equal, other is unequal. So then it is called as non-uniform motion. So this graph or curved line is an example of a non-uniform motion. Suppose if anybody asks you how to represent non-uniform motion on a graph paper, non-uniform motion on a graph paper, what we have to tell? We can represent with a curved line. We can represent with a curved line. How to represent uniform motion? With a straight line. So same kind of motion only we are representing on the graph line. But on the graph line, what we have to take care? There should be a x-axis, there should be a y-axis. On the x-axis, time you have to mention. On the y-axis, distance you have to mention, and you have to draw a curved line. You have to draw a curved line. Okay. Okay, any doubt regarding this non-uniform motion? Here non-uniform means here we have two factors. One is distance, other one is time. Distance, time. Here what we can tell? Distances may be equal, time may be different. Distances may be equal, time may be unequal, or time may be equal, distances may be unequal. Distances may be unequal means one quantity to be equal, other quantity unequal. So then we can tell that it is exhibiting non-uniform motion. Okay, is it clear? Is it clear? One should be equal, other should be unequal. In the case of uniform motion, both are equal. Time intervals are also equal, distances covered also equal. But here one should be equal, one should be unequal. Okay, next. Okay, let's learn about these terms: speed, velocity, acceleration. Already you might have learned this in 6th class and 7th class. Again, in 9th class we have a repetition of these topics. Speed. So actually, what does speed will tell? Suppose sometimes we make use of the word, the wind is coming with very great speed. The wind is coming with very great speed. Or if you are going on bike, what your parent will tell? Don't drive with more speed. Don't drive with more speed. Accident may happen. Like that he will suggest us or he will warn us. Here speed means a body, any body, it gives an idea about how slow or how fast the body is moving. So when we are moving on bike or when we are moving on any vehicle or on foot, so how fast we are going, how slow we are going, that idea will be given by the word speed. The idea will be given by the word speed. Okay, actually speed of the body, how to calculate speed of the body? Because we are traveling some distance. For suppose from point A, which is my house, from there I went to my friend's house, which is at point B. So there, A to B, I have traveled a distance. I have traveled a distance. For traveling this distance, I will take some time. I will take some time. The ratio of this distance by time is called speed. So speed is a ratio. So what is speed? Speed is a ratio. So ratio of what? How much distance we have traveled and how much time we have taken. That ratio is called speed. So distance travel is measured in meters. Time taken is measured in second. So the unit of speed is meter per second or centimeter per second. Or if you observe any bus, any city bus or private bus, so there they will on the front part of the driver's seat, what they will write, don't please drive carefully, not more than 60 kilometer per hour, like that they will mention. So here speed also measured in kilometer per hour, kilometer per hour, or else we can call it as kmph, kmph. So for measuring speed, we have different units like meter per second, centimeter per second, kilometer per hour. Like that we have so many units. What is speed? The ratio of distance and time is called speed. Okay, speed. Speed is denoted by the symbol V. Distance is denoted by the symbol S. Sometimes denoted by C, D, sometimes denoted by S. So V equal to S by D, means the distance by time, where V is the speed, S is the distance travel, T is the time taken. This is the formula for speed. Okay, here you can observe speedometer. In the vehicle like car, inside the car we will have speedometer. What the speedometer will tell? It will tell the speed of the car. It will tell the speed of the car. So next, we have some types. We have some types called like average speed. We have some types of speed like average speed, uniform speed, non-uniform speed, instantaneous speed. Let's see about average speed first. Average speed first. So actually, the average speed means, already we know what is the meaning of average. Actually, during the exams, so after the exam is completed, so you might be knowing about these words: subject average, class average. Suppose in one subject, one boy has got 30, another boy has got 50, 40, another boy 50, another boy 60. Like that, marks in physics subject. So what is the average mark? We have to add all, and how many quantities are there? 4 are there. We can add all, we can divide by 4. Okay? So that means sum of the elements by number of the elements. Sum of the elements by number of the elements. Here average speed means the total distance traveled by the body divided by total time taken. Total time taken to cover this distance. Total distance by total time, if we divide, that ratio is called average speed. That ratio is called average speed. So the formula for average speed is total distance traveled by total time taken. Suppose here one bus, during its onward journey, it is going with 40 miles per hour. Here mph. mph means 40 miles per hour. During its return journey, it is traveling with 60 miles per hour. Now, what is the average speed in this case? Can you guess the answer? What is the average speed in this case? What is the average speed? Somebody asking about acceleration, we will learn later. Okay. What is the average speed? You can answer through live chat. What is the average speed? During onward journey, it is going with 40 miles per hour. During return journey, it is coming back with 60 miles per hour. So what is the average speed? Average speed means total distance by total time. Total distance by total time. Somebody giving answer 100, 50, 100 is wrong. Is 50 correct? What is the formula here? Total distance traveled by total time. Here what is 40? 40 is speed here. What is 60? 60 also speed here. What are you doing? 40 plus 60 by 2 you are doing. 40 and 60 are not distances. They are speeds. 40 and 60 are not distances. Here in the formula what we have? Total distance. But here what it is? Total speed, not total distance. So this is the, so actually, so what, so many, one common mistake what we will do means, because onward journey speed is 40 meters per hour, return journey 60 meters per hour, what we will do? We will add both and we will divide by 2 and we will tell the answer 50. But this is a mistake. This is a mistake because this is not the correct approach. Because during onward journey we have to take the distance as d. During return journey also distance is same. We have to take it as d and we have to find time in the first case. We have to find time in the second case. Then we have to calculate the average speed. Okay. So here so many of you given the answer 50. I am telling it is wrong. Why it is wrong? Because it is the average of two speeds. We should not take like that. Because what is the definition of average speed? Total distance by total time. Total distance by total time. Let's see the correct explanation. So here the calculation for average speed means, how to take it means, onward journey the distance is d, return journey also the distance is d. So therefore what is the total distance? 2d. What is the total distance? 2d. What is the total distance? 2d. Let us take it as 1. Now what is the time taken for onward journey? We know that velocity. We know that velocity equal to distance by time. Velocity is equal to distance by time. So now what is time? T will go here and we will come here. We can write speed by velocity. We can write, sorry, 1 minute. So let us take a distance symbol as d here. Distance symbol as d here. Velocity equal to distance by time. So then what is time? Distance by velocity. So during onward journey, what is the time? Distance by velocity means distance by 40 miles. Distance by 40 miles. So during return journey, distance by, while returning with what speed it is coming? 60 miles per hour. D by 60. So now what is the average speed? Total distance by total time. What is total distance here? 2d. 2d by d by 40, d by 60. What is the value of d by 40 plus d by 60? D by 40 plus d by 60. What is the value? we have to take LCM. We have to take LCM. What is LCM? What is LCM of 40 and 60? 120. What is the LCM of 40 and 60? 120. 40 3s are 3D. 60 2s are 120. 2 into D, 2D. So 3D plus 2D, 5D by 20. 5D by 20, how much we will get? How much we will get? 5D by 20 means after cancellation, we will get D by 24. We will get D by 24. So we can write here 2D by D by 24. Like this we can write DD will get cancelled. This 24 will go to the numerator. 24 2s are 48. So what is the correct answer? 48 miles per hour. 48 miles per hour. Okay. Let me explain once again. Dear children, please listen carefully. So actually, what mistake we have done? 40 plus 60 by 2 equal to 50 we have told. But this is wrong. Why means? We have to take what? We have to take with the help of total distance by total time we have to tell the answer. What is the total distance? D plus D, 2D. What is the total time? We have to find. Here, what is the time? So here, what is the time here? How to calculate time here? What is the formula of time? We know that velocity equal to distance by time. So then, what about time? Time equal to distance by velocity. Distance by velocity. Here, what is the distance? D. What is the distance? D. What is the velocity? 40. So here, what is the time? D by 40 is the first time. Like this, what is the second time? During return journey, D by 60 is the second time. So total distance is D plus D, 2D. Total time is D by 40 plus D by 60. If we add D by 40 plus D by 60, what we will get? The LCM is 120. For 40 and 60, the LCM is 120. 40 3s are 120. 3 into D, 3D. 3 into D, 3D. 60 2s are 120. 2 into D, 2D. 3D plus 2D, 5D. 5D by 120. After cancellation, what we will get? Total time D by 24. What we will get? Total time D by 24. Okay. Total time D by 24. So here, total average speed means total distance by total time. What is total distance here? What is total distance here? 2D. What is total time here? D by 24. D by 24. So okay, this DD gets cancelled. 24 will go upwards. It will become 48 miles per hour. Actually, we have some shortcuts also for solving these kinds of problems, which we will learn while solving the problems. We will learn through shortcuts. Okay. Do you have any doubt regarding this? Do you have any doubt regarding this? Okay. While solving problems, we will get more kind of examples like this. At that time, we can practice with the help of shortcuts. Okay. So next. So this is about average speed. So next. Uniform speed. So uniform speed. If you take the example of ceiling fan or the example of hands of clock, hands of wall clock, or these we call them as blades of ceiling fan. If you observe the motion of blades of ceiling fan or hands of wall clock, seconds hand, minutes hand, or hours hand of wall clock, what do we observe? They will move in different directions. They will move in different directions. Their direction is not constant. Their direction is not constant. Hence, we can tell that they are moving with speed. How do they move? How do they move? Because they travel equal distance in equal intervals of time, no matter how small these time intervals may be. So these kinds of motions, we can call them as they are moving with uniform speed. They are moving with uniform speed. If you change the speed of a fan, its speed will change. But until if you keep on same speed, they will move with the same speed. They will move with the same speed. Okay. This is about uniform speed. Means traveling equal distances in equal intervals of time. So instantaneous speed. Instantaneous speed. So instant. You know about instant coffee. You will come across TV advertisements. Brew instant coffee. Why we call it as brew instant coffee? It is not like filter coffee. Filter coffee means night we have to make it filter. With that powder we have to make it filter. Morning we can make filter coffee. But brew instant means we can take the milk, we can mix brew powder, instant. By instant we can have coffee. So instant means at that particular time, at that instant, at that instant. So here speed at one particular instant, we call it as instantaneous speed. Speed at one particular instant, we call it as instantaneous speed. Suppose here the car has started its journey from here. From here it is moving like this, like this, like this. It is moving in curved line. It is moving like this. Throughout this entire journey, speed is increasing, increasing, again decreasing, again increasing, increasing, decreasing. This is the speed curve. But this straight line is the average speed. This straight line is the average speed of the car. But at this particular point, if anybody asks what is the speed of car, so that speed we can call it as instantaneous speed. So instantaneous speed never depends on whole journey of the car. Whole journey of the car. It depends on only that particular instant. That particular instant. Whereas average speed depends on throughout the journey of the car. Throughout the journey of the car. Because average speed means total distance by total time we have to take. But instantaneous speed means speed at that particular instant. Speed at that particular instant means speed between very small intervals. Speed between very small intervals. At that instant we call it as a instantaneous speed. Suppose if you observe pulsar bike, if you observe Bajaj pulsar bike, there you will be having digital speedometer. Digital speedometer. Here 188 km per hour. So what does it represent? At that particular instant, when we rise the accelerator, at that particular instant, what is the speed? Only at that moment only it will show that number. If you decrease the speed, automatically on the digital speedometer, the speed will be decreased. If you increase the speed, speed will be increased. So the digital speedometers, the use of the digital speedometers is they will show instantaneous speed values. Instantaneous speed values, so that you can take care of the speed. You can make the vehicle in control. Okay, that is about instantaneous speed. So somebody asking, any doubt regarding this? Sir, instant means a second. Somebody asking, is it a second? It's not compulsory a second. We can tell that very small interval of time. Very small interval of time. Okay. So next. Okay. Okay, about this velocity we will learn in next topic about this velocity. So about this velocity we will learn in next topic. So today what we have learned about uniform motion we have learned. So this distance time graph, it will show uniform motion. Non-uniform motion means in equal intervals of time covering unequal distances. Non-uniform motion will be represented by a curved line. Next, speed, velocity, acceleration. Here speed will tell how much fast or how much slow we are going. Speed formula, distance by time. So next, what is average speed? Average speed means we should not calculate like this. This is wrong. Average speed, how to calculate? Total distance by total time. Total distance by total time. Like that we have to calculate. Uniform speed, the blades of ceiling fan, the hands of wall clock, they will show uniform speed. Instantaneous speed means the speed at one particular instant, at one particular time, particular very small interval of time. Instantaneous speed will be shown by the digital speedometers or normal speedometers. Here average speed depends on whole journey, but instantaneous speed never depends on whole journey. Okay. So remaining next topics we will learn in next video. So thank you for watching our video. Please subscribe our channel and press the bell icon for receiving